solve another question on paper 1B today. So now this investigation is about refraction through a semicircular glass block as given in this diagram. So what is happening in this question is a light from a ray box. So this is a ray box that is drawn. Okay, so a light from the ray box enters the curved side of the block. This is the curved side of the block. It is entering from this side, as we can see in the diagram. The light passes through the block and leaves refracted at P. So at P, the refraction is taking place and light leaves the block. So the first question says that outline how the student can ensure that the light is not deflected at the curved surface. So in order to not get it deflect, right, so incident angle over here must be 0, or in other words you can say these light rays should be falling perpendicularly on the surface, exactly 90-degree at that point. Okay, so we can say that the incident angle of incidence has to be 0. At where, it's very important, just has to be 0 is not enough. You have to write where it has to be 0, at every point of incidence. Cool. Now let us move to the second part. So the second part says one of their measurement is shown. State theta r for this measurement. So they have given another diagram. Okay, this measurement is given. So they want us to find out angle of refraction, right, theta r. So angle of refraction is, for let me just quickly draw it. So for that I have to draw a normal. A normal is a line 90-degree on the surface. So this is a normal. So the angle between a reflected ray, sorry, incident ray and the normal ray, this is angle of incidence in this case. You see the arrow is here, so light is falling at P, and this angle is the angle of refraction. Angle of refraction is the angle between the normal ray and the refracted ray. So you see here this angle. So if I measure it correctly, like I will zoom in onto it. Okay, so angle R somewhere is this one, right? So I can measure this angle. So this angle is 41, but I want angle R, which is purple angle, and this entire thing is 90. So the angle R is going to be 90 minus 41. Many students do this mistake. They quickly write 41, forgetting that they are measuring this angle. But we don't want this black angle. We want this purple angle, which is angle of refraction. So angle R comes out to be 49 degrees. 90 minus 41. So yeah, so it's very important that you write 49 degrees over here. Okay, now in the second part, they have given a table. They want us to complete the table. Very simple. So theta I is given, angle of refraction is given, sine of theta angle of incidence, and sine of angle of refraction. So this value is missing. Very simple. So I'm supposed to find out sine of angle of refraction. So what is the angle of refraction here? 49. So sine of 49, if I put that in the calculator, I get 0.7553 something something something. But see, because every other value is given with 3 decimal points, so it's very important that you write this value also with 3 decimal points, so which becomes 0.755. Okay, cool. Now let us move to the next part. They plot a graph of variation of sine theta I with sine theta r. So basically, now the student is drawing a graph between a sine of angle of refraction to the sine of angle of incidence, and he adds uncertainty bar also for the first and last data point. Okay, cool. First and last data points is given. Um, okay, and draws the best fit line. He has drawn a best fit line also. Cool. Determine the gradient of the student's best fit line. So now we are supposed to find out the gradient for this graph. So to find out gradient, make sure that you take 2 points which are, which are a good distance away from each other, at least half of that, more than half of that line. So the 2 points that I choose, one point is this, so I can call it as 0 0.2, and this has to be 0 0.3. 0 0.3. Okay, and the other point that I choose is this. Okay, so this point is 0 0.7, comma, and if I see how much this point is, so 1 2 3 4 boxes is giving you 0 0.2. So one box will be 0.2 divided by 4, which is 0.05. So this point is going to be 1.05. Okay, cool. So now I have 2 points. How do we find out gradient? So gradient is calculated as y2 minus y1 over x2 minus x1. This is the formula. So if I say this as x1 comma y1, this point will become x2 comma y2. Now if I put the values, y2 minus y1, y2 is 1.05 minus y1 is 0.3 divided by x2, which is 0.7 minus x1, which is 0.2. So if I solve it over here, so I get the value of gradient as 1.5. So I get the gradient as 1.5. Cool. Now in the second part, they're asking draw on the student graph the line of maximum gradient. So it's very important. So let me teach you how to draw line of maximum and minimum gradient. So to draw the line of maximum gradient, what you have to do is take the last point of the uncertainty bar and match it with the maximum, the highest point of the uncertainty bar. So this green line is line of maximum slope or maximum fit. Okay, similarly, if I had to draw a line of minimum slope or minimum fit, I have to take the top of the like to the first point's uncertainty, have to match it with the bottom of the first point's uncertainty. So if you see this purple line, this is line of minimum slope. So I've drawn both. So black one is the line of best fit, okay, green one is the line of maximum slope, and the purple one is the line of minimum slope. Cool.